simplification in logarithmic. For an example, when you have log base 5 25 plus log base 5, the answer is 4. Okay, there is an addition. Okay, there is an addition. How can we do the question? Okay, this is the simplification in logarithmic. So in this case, the bases are same. Okay, try to understand this. It's really easy. Log base 5, here also log base 5. That means in our answer also same base, log base 5. In logarithmic notation, if there is any addition, okay, in logarithmic notation, there are two individual addition. When you bring that to a final answer, in that case, the addition will become a multiplication. Okay, addition will become a multiplication. So 25 times 4, final answer would be log base 5, answer would be 100. This would be the final answer. Okay, why we are doing like that? In previous questions, I explained you 2 to the power of 5 multiplied with 2 to the power of 3. 2 to the power of 5 multiplied with 2 to the power of 3. If the same bases are same, while multiplication you can add your powers. While multiplication you can add up your powers. Here we are doing the converse thing. Here this is in logarithmic notation. So bases are same. If there is any addition happening, you should multiply in oppose. Okay. There is in index notation, the multiplication became an addition. Here the addition in logarithmic notation, the addition will become a multiplication. Addition will become a multiplication. This is the difference between index notation and logarithmic notation. Okay, I'll explain again by using another example. Here we have log, not log, LG 50 plus LG 5. LG 50, LG 5. LG 50 means, let's write the abbreviation. So log base 10 value 50 plus log base 10 the value 5. Okay, I told you that in logarithmic notation, if there is an addition, that will become a multiplication. That will become a multiplication. The base is same, log base 10. There are two individual additions, 50 plus 5. So 50 plus 5, we cannot operate it as 55. So in logarithmic notation, if there is any addition, that will become a multiplication. 50 times 5. 50 times 5. So the final answer would be log base 10. Okay, I'll write over here. Log base 10, 50 times 5, it's 250. 50 times 5, it's 250. This is the way you should do the logarithmic simplification. If there is any addition, will become a multiplication. Similarly, if there is any subtraction, that will become a division. That will become a division. That's the thing we are going to study after here. Okay, then after log base x. Okay, base x, we don't know what it this x indicates, but log base x 18 minus log base x 3. Okay, minus 3. We are going to operate this logarithmic simplification. So the bases are same. Without same bases, we cannot do like that. With same bases only, we can do. So log base x, if there is any subtraction in logarithmic notation, that will become a division. So 18 should be divided by 3. 18 should be divided by 3. That will become log base x. 18 divided by 3, it would be 6. It would be 6. This would be the final answer for the question. This is the maximum simplification we can operate. Then let's try one more question. Log base 2 5 plus log base 2 value 4 minus log base 2 2 2 2. Okay. What do we need to do? The bases are same in all three cases. There are three logarithmic values. So here log base 2, log base 2, here also log base 2. In final answer also it would be log base 2 as well. First of all, there is an addition. 5 plus 4. That means in logarithmic, okay, in logarithmic, if there is an addition, that will become multiplication. 5 should be multiplied with 4. 5 multiplied with 4. There is a subtraction. Subtraction means divide by 2. Divide by 2. This is the way you should do the operation. 5 multiplied by 4 is 20. 20 divided by 2 would be 10. So log base 2, the answer would be 10. Answer would be 10. This is the way you should try the second question respectively. Let's do a quick recap. Okay, here log base x 18, log base x 3. Okay, the operation between these two logarithmic notation, that's subtraction. Subtraction means, okay, when you bring it together, subtraction will become a division according to logarithmic rules. So 18 divided by 3, it would be 6. The base same, no? So log base x, the value would be 6. Thereafter, in the second question, we have too many operations. The bases are same. Okay, don't worry about it. So thereafter, we have an addition, that means multiplication. 5 times 4, it's 20. 20, then there is a subtraction, so that would be a division. 20 divided by 2, it will give you 10. Log base 2, the value would be 10. Very easy. Addition became multiplication and subtraction became division. That's the only thing. Okay, in the first one, the bases are same. That's the first thing you should note. The bases are not same. We cannot do the operation with these logarithmic values. So here log base 2, here also log base 2, in third case also log base 2. So then in final answer also it would be log base 2. Log base 2. Let's do the operation direct. The first of all, there is an addition. Addition means multiplication. 5 times 7, it's 35. 35. Then after subtraction, that means division. 35 divided by 1. 35 divided by 1, that would be 35 again. 35 divided by 1, that's 35 again. Then in the second one, all the cases log base 7. Okay, all log base 7. That's easy. Then after here we have a subtraction. 22 minus 11. That means 22 divided by 11. 22 divided by 11, it's 2. It's 2. So then after that 2 should be multiplied with this 3. Addition, that means multiplication. 22 divided by 11, it's 2. 2 times 3, it would be 6. 2 times 3, it would be 6. That's easy. In the final one, let's try that one now. In that, there are some combination of questions. Okay, I'll raise. Yeah. In the third one, LG50. LG50. Okay, let's denote it with the base. Log base 10 50 plus log base 10 3 minus log base 10 2. 10 2 minus LG5, that means log base 10 5. Okay, you should write like this before doing the final calculation. When you denote it something like this, it's beneficial. Otherwise, sometimes you will get confused how this one came from, how this LG became something like that without bases. How can we operate these logarithmic values? There are some misconclusions. No? So that's why it's better when you denote every value with a proper base. Here you have a proper idea. All the bases are same. So in final one also it would be same as well. Log base 10, log base 10, let's do the operation. So 50 plus 3, that means 50 multiplied by 3. 50 multiplied by 3. Then after there is a subtraction. Okay, that's a subtraction. That means this value should be divided by log base 10 too. Again also this one also a division. Okay, a respective division. Look at this. Here there's a multiplication. Then there's a division. Again also there is a division. Okay, there's a division. This is the way you should write this. This is the way you should denote. Then finally log base 10. Log base 10. 5 times 2 it's 10. Okay, 5 times 2 it's 10. 5 times 2 it's 10. In numerator we have 50 times 3 it's 150. In denominator we have 2 times 5 it's 10. So 150 divided by 10, that will give you 15. That will give you 15. I'll repeat it again. Here there is an addition that became multiplication, and there are two following subtraction. That means those are divisions. Okay, division itself. So then after 50 times 3, okay, we can do that directly as well. Okay, 50 times 3 it's 150. Divide by 2 it's 75. 75 divided by 5, again it will give you the final answer as 15. Final value as 15. That's the way you should try the question.